Hello and welcome again to our class, and today we're going to study about a very special topic to me, which is about measurement. Now what does measurement really mean? So let's try to see that if we have this park, we have this park and we want to actually go around and cover some distance on this park. So how will it function? For example, I come out of my home over here, and I just want to enter and just at the boundary of this park over here, let's say this is point A over here, and I just keep on traveling over here to point B, and again I come over here and keep traveling over here to point C, and then again I come over here and keep on traveling over here to point D, and let's say again I come over here and I make a whole circle. Not a circle but a whole round. So what exactly can be measurement for this? So one thing which we can do is that probably we will want to measure to the size of our feet. So like sometimes we play cricket, so we like 1, 2, we measure like feet. So you can measure through your feet. So like 1 feet, 2 feet, 3 feet, 4 feet, 5 feet, 6 feet, 7 feet. So this would have been one of the traditional ways, one of the old ways of measurement. Now just hold on over here, and what if I want to measure the size of this board? So when I try to measure the size of this board, what can be my measuring tool? So I'll just look around my body and I think, okay, what can I use for measuring? So I think probably I'll just use this pen. So 1, 2, 3, 4, 5, 6, and 7. So 7 rounds of this pen will give me one of the ends. But I think this might vary a little bit depending on the size of a pen. If I have a different pen, it might change. So probably I'll see, okay, what will remain same. For example, I go to a place, I don't have this pen, so which tool can I use? So I see, oh yes, I have my hand, so I can use like this, like 1 and 2 and 3 and 4 and 5 and 6 and 7. So in old days, I don't know how many of you saw that we used to measure length this way and breadth this way. 1 and 2 and 3 and 4 and 5 and 6. But the little problem with this kind of measurement would be, can you imagine? Yes, like I have a short hand, so my measurement will be short. And if somebody is very bulky and big and huge, so they have a big hand. And if somebody is shorter than me, then yes, they have a shorter length. So in these kind of scenarios, when we used to use our feet or hand, or let's say sometimes we can use the whole hand like this. So how many of you actually went for a trip to market and with your mother for shopping? And how many of you saw your mother buying these things, which basically we call clothes? And what about the raw cloth? Raw cloth. So if they are buying raw cloth, the measurement comes into, yes, the measurement comes into something called meters. So have you seen the shopkeeper saying that how many meters cloth do you want? So they will say, okay, let me measure. I'm holding 1 meter and 2 meter and 3 meter. Do you do something like this? Yes, I always saw that. And what happens is, the exact measurement which they actually want to do is 1 meter. Any idea how many centimeters would that be? Well, yes. So that would be approximate 100 centimeter. Some other class will definitely try to prove that why this is 100 centimeter. But in this particular class, we actually want to focus that what will be the measurement when I want to, let's say, travel around the objects. Let's say this park. This park, I want to travel around here. So what happens when I travel around this park? So if I travel through my feet, so obviously I can measure the number of feet over here. But the problem is, let's say I have traveled around this and I've seen that it comes out to be 100 feet. But what happens if my friend is walking and he's a bit tall? So he have a different feet size. So probably with a big feet size, do you think now it should be 100 feet or lesser than 100? Yes, with a bigger feet size, it would be less. Probably it can be 90 feet. And what if somebody has lower feet size than me? So yeah, the foot size, if it is less, so number of feet will increase. It can be probably 110. So what someone did in old days, probably they calculated, especially I think in the world called Europe, in European world I think, because they are quite heavy and very tall people, so they have big feet size. So I think they thought, okay, let's have this feet size, 1 feet is equal to 12 inches. Cool. So according to European standard, some group of people might have standardized, okay, 1 feet will be 12 inches. I'll just make it clear. It will be 12 inches. And how can that be converted into centimeters? So it's basically what we can do is that we know how much inch is in centimeter. So we know 1 inch is equal to 2.54 centimeters. So when you multiply 2.54 by 12 inches, you basically get some sort of idea in centimeters, which is close to 30 point something. Yeah, so you can calculate and get that. Now what we want to see, that again coming back to our topic, that what kind of measurements we can have. Let's see these kind of pictures over here. What if I go around this? Yeah, and what if I go around these? So let's come back and try to see for different kind of images that how can we find the different kind of measurements. So I'll just remove these feet over here, and I'll also remove the inches over here and come back, and let's see what happens. So let's say over here, when we are walking, I'll just try to imagine a few lengths. Let's see, my length over here is coming out to be, what do you want to imagine? Let's say this comes out to be 60 meter over here, because the park might be big. Yeah, let's say I'm walking 60 meters over here, and let's say I'm walking over here, and this might be a small park, I believe. So this might be like 60 meter across, let's say 40 meters. Yeah, and since this seems like a rectangular park, so what I may want to do is that probably I'll try to figure out that the side over here, this would be exactly same at the opposite end. So if it's 60 meters, let's say this will also be 60 meters. Yeah, and if this 40 meters, then this also will be 40 meters. Now coming back, so when I'm walking around this park, by the way, we must be very clear that we are walking outside or we are walking inside. Yes, we are walking outside the park. So the inner part actually we are not considering right now. We are just talking the outer part right now. Yeah. So when you calculate it and you get the sum of all the sides, let's say I get this side 60 meters, which is like A, B, C, D, which is like AD. And if I add this 60 to, let's say, this 40, which is my AB, and if I add this to BC, so this comes out to be 60, and if I add this to CD, which comes out to be 40. So what happens over here, that when we tried, and obviously all of them are in meters, so when we try to add all of them and we try to get this sum, we get something called perimeter. So perimeter essentially is sum of all sides. Probably you may want to write this, perimeter of sum of all the sides. And is it outer or is it inner? Yes, it's outer. Now what if I get a shape which is very strange like this one? Yeah. So how can I calculate the perimeter for this? So probably I'll just rub and try to find the perimeter out of this shape. So I'll rub this over here, and a little bit of movement, sorry for that. I'll rub this. So let's try to replicate this shape over here, and I'll put this. So I'll try to make the shape, let's say this shape is like this, yeah, and there's a little bit of V shape inside, and let's put at the point A, B, C and D. And again the whole story goes this way, that I'm standing over here, yeah, let's say I'm traveling like this, so I'm traveling over here. So how much distance? A, B I'm traveling, and let's say I'm traveling over here, so this is A and D, and let's say I'm traveling over here, so this is C, D, and let's say I'm traveling over here, this is B, C. So let's confirm A, B, A, D and D, C or C, D and B, C. Now when I get the sum of all these sides, essentially what I'm looking for is something called perimeter. Now what if I'm wondering the shape might be, let's say, like this, yeah, the shape might be like this. So I would want draw this picture again, and let's replicate. This is a perfect rectangle, and probably if I'm dividing this way, yeah, and still I want perimeter. So what do you think the perimeter can be? They have divided it from between and they're still trying to find the perimeter. So let's think. I'm giving you 10 seconds to think, and let me also think. Okay, so this is the picture. They have divided it from between. What can be the perimeter? So the perimeter, I should know, first thing, is it outside or is it inside? So I know, yes, the perimeter comes outside. So does it really matter that how many divisions you are doing inside? Does it really matter? Anyways, you're not going to enter inside? No? Yes. So when you're not going to go inside, you're going to travel outside. The perimeter anyways doesn't matter over here, unless until you want area. We are not doing area right now. So let's see how much perimeter can this be. So again, if this is, let's say, this is 10 meters and this is 40 meters, from here till here, the opposite will be same since it's a rectangle, 40 meters, and this will be 10 meters. Now when you get sum of all these sides, you will get something like this. You will get 10 plus 40 plus 10 plus 40. So which comes out to be 50 plus 50, and which comes out to be 100. So you get 100 meters. You can put the unit later, or you can just keep adding it on a bracket. You can keep add meter, and you can keep adding meter over here. Now what if I have a triangle shape like this? So we have two kind of triangles. One triangle is coming like this over here, the other triangle is coming this way, yeah. So let's try to see these kind of pictures as well, that what can be perimeter. So I'll just rub this over here, and I want to delete this. Let's rub. Okay. Now one pattern which you may want to see over here is that in rectangular shapes, what is happening? The opposite sides are same. In rectangle, the opposite sides are same. Now will the same happen in case of triangle? Let's try to see if the same pattern repeats or not. So when I make a triangle like this, and I want to derive something called perimeter. And what is perimeter? Yes, perimeter is sum of all sides, right? Now I'll try to use this, sum of all sides. So let's say I find this as, let's say, 10 meters, and this as I find 15 meters, and this one, let's say, it seems to be bigger, so let's say I take this as 20 meters. So what is the perimeter? Sum of all sides. So when I take sum of all sides, I will want to consider it this way, like ABC, so which is equal to AB plus which is equal to CB or BC, and also it's equal to AC or CA. Now AB comes out to be 10, BC or CB comes out to be 15, and CA comes out to be 20. Now this goes this way, 25, 10 and 15 comes out to be 25. How? 10 plus 10, 20, and plus 5, 25, plus 20 is equal to 45 meters. Right. Now, finally, when we have understood what our perimeter, now let's try to understand what can be our area. And area is probably the most exciting thing which we will study. So let's try to just wait another few minutes and see what is the area. Now, I'll just rub this over here. And let's try to start with the simplest of example. Okay, so now we'll do area as well, but let's try to have a figure for your homework. And what we'll try to do, we'll try to have some figure like this, let's say. Yeah. Let's try to make this figure extended like this. And what if I try to give you some dimensions? Probably you can find the perimeter for this. Yeah. So I have this part, let's say it's 2 centimeters. This is 2 centimeter. The same, this part is again 2 centimeters. You may want to put arrow like this as well. And this length over here, let's say this length is 10 centimeters. Similarly, the opposite would be 10 centimeters. And this part, let's say it's 5 centimeters from here till here, and this one is again 2 centimeters, and this part again 2 centimeters, and this part over here, let's say, is again 10 centimeters, and the opposite one, this one, would be same as this, which I'm not putting, but I'm putting that as x. Now what you need to find is, you need to find this as perimeter as your homework, and let us know if you're really able to find the perimeter of this whole picture, considering that perimeter is outside and not inside right now. Okay, so now after this, let's try to jump into the world of areas. So I'll just rub this way, and let's try to see what is an area. So the figure which first comes to my mind for finding an area is, let's say, this board. Yeah, this board. So the dimension of this board, somebody just told me, is actually 4 by 3. 4 by 3. Now what is 4 by 3? So I'll just take it's 4 by 3, and that comes out to be, by the way, in feet. Cool. So let's try to figure what is 4 by 3. So I'll probably just start with this, that this 4 probably means the length part, yeah, and this 3 probably means the breadth part. Now what the actual figure will look like, probably I'll divide this board like this, but it's not virtually possible because I'm using the board. So why don't I create a dummy board on the board itself? So let's say this hole is my board over here, this hole is my board over here, and I want to divide it into, let's say, 4 parts by 3 parts. So let's try to figure, if this is my starting point over here, so this is my 1 part, and this is my 2 part, and this is my 3 part, and this is my 4 part. So this comes as 1 and 2 and 3 and 4. So this way probably I want to reduce its size like this, since it's 4, and now I want to limit it to 3. So let's say this is my 1 part, and this is my 2 part, and this is my 3 part. Now probably I'll reduce my size over here. So what this essentially means, that when I divide into 4 by 3, I want 4 divisions over here, and I want 3 divisions here. So let's say I have 1 division, and 2 division, and 3 division. Now I want something called area. Something called area. So area, if you ever realize, when you ever go to market, the area always come in square of something, right? So either it can be square centimeters, or square of meters, or square of anything virtually. You can find square inches, or square feet, but it will be always square. Sometimes in large distances you may find square kilometers, yeah, but the square will always be there. So what is this square, 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 square? So this square probably indicates that area is associated with something related to square. Now let's try to divide and see if we can divide these into number of squares. So what I'll do, I'll put small dots over here, vertical dots. Already I have 4 divisions over here, and probably I want to put some horizontal dots like this. And now probably I just want to count number of squares. Now we know that we are doing it approximately, so this exactly is not a square, but let's assume that they are squares. So how many squares do we have? We have 1 square, 2 square, 3 square, 4 square, 5, 6. Can you count? Well, yes. Some of you did it fast. How do you did it fast? You counted this as 1, 2, 3, 4. So this is 4 over here, and this is 3 over here. So let's say 4 into 3. So 4 into 3 must be the same as what we are counting. And what were we counting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my god, 4 into 3 is 12, and the number of squares are 12. So what we write? It's equal to 12 square. Let me write it correctly. Square units. So the area is 12 square units. Now what is the unit over here? If you're talking about feet, it would be feet. If you're talking about centimeter, it would be centimeter. You just need to replace with unit. So over here, I'll just leave it to you that whichever unit you want to use it. But the word over here important is square. Now let's talk about this picture over here. It's very small, so I'll take the liberty to get it close to you, and you may want to just see this picture over here, that what does this represent. I'll just rotate it, and it has probably a lot of squares into it. Now let's try to see that if I want to measure its area, how do I do it? Now I'll just drop this picture over here, and just in a couple of minutes we'll try to figure out that how do we find its area. Okay, now let's get started. I'll first try to replicate this model on the board. So when I try to replicate this model this way, probably I need more slant line like this. No, probably I want to extend it horizontally like this, yes, and then we want to extend it this way. Now I think it's kind of replicated, yeah? Yes, thank you. So now we have one slant line which I'll name as A, and then I'll name as B, and then I'll name as C and D. Done? Oh my god, I missed something. What did I miss? Yes, I missed this little point. So, a moral story. In life, never ever underestimate the little things. The little things are very important. Yeah. So now over here, let's again start A, B, C, D, and our little thing is very important, which is E. Cool. So when we want perimeter, let's revise perimeter. What is perimeter? Outside or inside? Yes, you're right. It will be outside. So perimeter is sum of all the sides. Now how many sides? Somebody said 4. Let's say 1, 2, 3, and 4. Yes, you got it. It's not 4. It's 1 and 2 and 3 and 4. And fifth one, the small one, is the fifth side. So if you want to find the perimeter, it will be sum of all the 5 sides. But what about the area? So for area, yes, I'll just divide it into number of horizontal lines like this. And then probably I want to divide it into number of, these were the vertical lines, I'm sorry. I'll divide into vertical lines, which is like this, and horizontal will be like this. So when I'll divide into number of horizontal lines, the next few steps will be just like counting the number of square units. Now I know it will take a lot of time to count the square units, But let's say if I got the whole squares, so yes, I will count them as 1, 2, 3, 4. But what if I'm getting just half the squares? So I'll calculate half the squares like this. Yeah, let's say I got 1, 2, 3, 4. I got 4 halves. Yeah, so how many 4 halves will make one square? So what I'll do is I'll probably do it like this. I'll just write number of 4 halves. Number of 4 halves are 4. And how many are halves are these? I'm sorry, number of 4 halves are 4. So I'll simply write 4 halves. So when you multiply this by halves, you get 2. So what probably we want to do is we'll count the number of big squares, we'll add them with the number of halves, and then finally the number of square units will come out as your area. And for you, I'm just hoping that I'll just show this picture close to you and you'll replicate this at your home, and through this you just try to find two things. One is perimeter, which is outside, and one the area, which are nothing but number of square units inside. Thank you. Have a nice day.